Hello students, we are still on the sum of geometric progression. Sum of a geometric progression. Now let's consider this example. We are given that the third and sixth terms of a geometric sequence are 0.9 and 0.0243 respectively. Find one the common ratio and the first term. Common ratio and the first term. 2. The general term. Then 3. The 10th term. 4. The sum of the first 10 terms of the sequence. Sum of the first 10 terms of the sequence. So first of all, since this we are talking about a geometrical progression, so that means we are going to use the formula. The end for the n term is equal to a r raised power n minus 1, and we are told that the third term is 0.9. So if you're having the third term is equal to, if substituting to here, the first term we don't know, r we don't know, n here will be what? 3 minus 1 is equal to 0.9. So 3 minus 1 will give you what? 2. AR square is equal to 0.9. You take this to be your equation 1. Now, the second one says that the sixth term is 0.0243. So, again, you are going to substitute into this formula. So, for the sixth term is equal to AR. In place of n, you put 6 minus 1 is equal to 0.0243. So 6 minus 1 will give us 5. AR raised power 5 is equal to 0.0243. Take this to be equation 2. So for us to be able to solve this equation 1 and 2 simultaneously, you will divide equation 2 by equation 1. So divide equation 2 by equation 1. When you divide equation 2 by equation 1, so this is equation 2, AR raised power 5 is equal to 0.0243. Our equation 1 is AR square is equal to 0.9. So that means you divide them by each other. Now you have AR raised power 5 divided by AR square is equal to 0.0243 divided by 0.9. So A divided by A cancel A, remaining R raised power 5 divided by R raised power 2. So if we use indices, you have 5 minus 2. So because they are dividing each other, so 5 R raised power 5 minus 2 is equal to 0.0243 divided by 0.9 will give you 0.027. So that means you now have what? R raised power 5 minus 2 will give us 3 is equal to 0.027. Now to get R, this is cube. Bring this cube to come and use it to find the root of this. Whenever R cube crosses a equality sign, it will now turn to cube root. We now use it to find the cube root of 0.027. So the cube root of 0.027 is what? 0.3. So the value for R is equal to 0.3. So now since you have got the value for R to be 0.3, substitute R is equal to 0.3 into equation 1. So when you substitute it into equation 1, A times R is for 0.3 square is equal to 0.9. So A times 0.3 square is equal to 0.9. So A times 0.3 square is for 0.09 is equal to 0.9. So when you divide both sides by what? 0.9, 0.09. So 0.09 will cancel 0.09. You have left with A here. 0.9 divided by 0.09. That means our A is what? 10. So here you realize that your first term is 10 and your common ratio is what? 0.3. The first term is 10 and the common ratio is 0.3. So the question, the second part says that we should look for the general term. So that means the general term for this particular GP, what will be the general term? So that means you are going to substitute into the formula for the n term. Substitute the value for A which is 10, and the common ratio is 0.3. So when you substitute 10, n term will now be equal to 10 times 0.3 raised to power n minus 1. So this will now be the general term for this particular GP. From there, you are now told to look for the 10th term of this GP. So the 10th term will now be well. So for the 10th term, we can still use this general term for this particular GP. So you now take this to be the formula till the n term will now be 10 times 0.3. In place of n, you now put 10 minus 1. So that means we having 10 times 0.3 raised to power 9. So 0.3 raised to power 9 will give you 0.000019683. So when you multiply this by 10, you are going to get 0.000019683. Then the fourth part of the question says that the sum of the first 10 terms of the sequence. So the sum of the first 10 terms of the sequence. To look for the sum of the first 10 terms of the sequence. So here you realize that the value for R here, the common ratio is 0.3. So this is less than 1. So since the value for R is less than 1, you are going to use this formula. A into bracket 1 minus R raised to power n over 1 minus R. So your first term here is for 10 into bracket 1 minus R is for 0.3 raised to power 10. Everything over 1 minus R is for 0.3. So what is 0.3 raised to power 10? Which should give us 0.000059049. Then you have 10 into bracket 1 minus d over 1 minus 0.3 is what? 0.7. So when you subtract this 1 minus this will give us 0.999994091. If you multiply this by 10 then and divide it by 0.7, you are going to have 14.2856. So to one decimal places, you are having what? 14.3. You are having 14.3. Now let's look at the second question. The second term of a geometric progression is 3. If its sum to infinity is 25 over 2, find the value of the common ratio. So you are told that the second term of a geometric progression is 3. So the second term is what? 3. So if you substitute 3, if you substitute into the formula for the n term of a GP, Tn is equal to AR raised to power n minus 1. So when you substitute this, our n here will be 2 minus 1 is equal to 3. So AR is equal to 3. This is your first equation. That is what? Equation 1. And also you are given the formula, the value for the sum to infinity. If its sum to infinity is what? 25 over 2. So you are given the sum to infinity. The formula for the sum to infinity is for A over R1 minus R. So that means you are told that the value for this one and sum to infinity is 25 over 2 is equal to A over R1 minus R. So let's cross multiply. 25 times 1 minus R is equal to 2 times A will give us 2A. This is our equation 2. So now from our equation 1 is what? AR is equal to 3. So let's try to make A the separator formula. So this R, it is multiplying here. When it comes to this other side, to come and divide. So that means A will be equal to 3 over R. When we make R separator formula from this R will come here. So that means our A will be equal to 3 over R. So we now substitute A is equal to 3 over R into the second equation, into equation 2. So where we see A, we substitute 3 over R. So 2A is supposed to be here. We're having 3 over R. So we're having 25 into bracket 1 minus R is equal to 2 into bracket 3 over R. Let's try to open the bracket. So 25 times 1 is 25 minus 25 times R is 25R is equal to 2 times 3 is 6 over R. So from here, let's cross multiply. Let's bring this 6 to come and multiply here. R into bracket 25 minus 25r is equal to 6. Open the bracket. 25 times r is what? 25r minus 25r times r of 25r squared is equal to 6. So when you rearrange this one, this minus 25r squared plus 25. This plus 6, when it comes to now turn to minus 6 is equal to 0. So we are going to factorize. When we factorize, so that means we have minus 5r times 5r will give us minus 25r squared. 2 times minus 3 will give us minus 6. Let's check if it will give us what is in the middle. Minus 5r times minus 3 is plus 15r. 5r times 2 is 2 plus 10r. 50r plus 10 now is 25r. You can see it gives us. So that means the factors of this both minus 5r plus 2 and 5r minus 3 is equal to 0. So when you solve this, minus 5r plus 2 is equal to 0. Minus 5r will be equal to, this one will come in, now turn to minus 2. So divide both sides by minus 5. So that means your r here will be what? 2 over 5. Minus divided by minus will give us plus. So that means 2 over 5. So for this other side also, 5r minus 3 is equal to 0. When minus cross equality sign, now turn to plus 3. So divide both sides by 5. So your r will be equal to 3 over 5. So the value for the common ratio will be what? 2 over 5 or 3 over 5. So that's what we are told to find. We are told to find the value of the common ratio. So the value for the common ratio could be 2 over 5 or 3 over 5. Now let's come to the work practice. For the work practice, number 1, the second and fifth terms of an exponential sequence GP are 1 over 2 and 1 over 16 respectively. Find 1. The first term and the common ratio of the exponential sequence. 2. The sum of the first 5 terms of the sequence. 3. The sum of the first n terms of the sequence. Number 2. The common ratio of a GP is 2 if the fifth term is greater than the first term by 45. Find the fifth term. Number 3. The second term of an exponential sequence is 9, while the fourth term is 81. Find the common ratio. Find the common ratio, the first term, and the sum of the first 5 terms of the sequence. Number 4. The fifth term of an exponential sequence is greater than the fourth term by 13.5, and the fourth term is greater than the third term by 9. Find 1. The common ratio. 2. The first term. Number 5. The sum of the first 2 terms of an exponential sequence is 135, and the sum of the third and the fourth term is 60. Given that the common ratio is positive, calculate the common ratio and the first term. Then number figure 2, the limit of the sum of the first n terms as n becomes large. Here it means you have to look for the sum to infinity. Then number 6, given that root 6, 3 root 2, 3 root 6, 9 root 2, and so on are the first 4 terms of an exponential sequence, find in its simplest form the 8th term. Please ensure you like, subscribe, and comment on this video. Thank you.